Although this class is probably going to be shorter than most other classes, well, I always say that, don't I? But we're dealing with a whole large family of tests called non-parametric tests. Okay, so I'm basically just going to give you the general idea of what these are. Going to give you a couple of basic examples of the most common ones, and I'm going to leave to your experience, future experience, to find out more of these tests and their particular features. Okay, so what are these non-parametric tests and why do we even consider them? Well, the basic question is the following: what can we use when the assumptions of a t-test or an ANOVA are badly violated? Now, I'm using t-test and ANOVA simply because they're the ones that we have seen, but the same question can be asked for many other tests that we have not seen yet or that we will not see in this course. The idea is that, remember, each one of these tests has some basic requirements. What are we going to do if those requirements are simply not sufficiently in place so that not even the robustness of those tests can do? For instance, let's say that the histogram of the data that we collect looks like this, so very skewed, or like that, we're very bimodal. In this test, as I said, we really don't want to use either a t-test or especially an ANOVA. Okay, so what are we going to do? Well, we can use other tests that do not use the missing assumption, so that we don't have to worry about it. In particular, when the Bell distribution is not present, like the one that the two histograms that I'm showing up there, then we're going to use non-parametric tests. So non-parametric tests are pretty much the ones where we're going to abandon the idea of the bell-shaped distribution. Technically speaking, they're a little bit more than that, but again, we're not going to dwell on the technicalities here, are we? So what is the basic approach that these tests take? The idea is the following. What we're going to do is we're going to ignore the actual values of the observations, and this is in case we're using ordinal or numerical variables. So in this case, the observation will have certain values. We're going to ignore them. Oh, by the way, those are of course the only kind of values for which we're going to use these tests, because for nominal ones we don't have values for which we have to worry about Bell distributions and so on. So in these cases, we're going to forget about the actual values and focus instead on the ranks. What we're going to be using are the ranks of each of the observation within the samples that we have collected. I'm going to give you just one example of how that works for one very common test. Okay, but this is the general idea used by non-parametric tests. Okay, so for instance, let's say that this is the sample of numbers we have obtained. As you can tell, there is at least one fairly significant outlier. The numbers are fairly crowded on the left hand side, and then there is a jump, and then there is a big outlier. Okay, so this doesn't look like these data are coming from a bell-shaped distribution. So what we're going to do instead is we're going to associate to each of these numbers their rank. Okay, so the lowest one will be rank number 1, second one rank number 2, and 3, 4, 5, and 6. Once we've done that, we're going to ignore what we had to begin with. Now notice that in this situation I ranked the numbers from the lowest to the highest. Actually, that's not really important. I can also rank them from the highest to the lowest, whatever makes more sense to the researcher and to you. However, the tests that we're going to be looking at work exactly the same way, no matter how you're going to rank them, from highest to lowest or from lowest to highest. Okay? So because of this, these tests are also referred to as rank-based tests, because all they use is the ranks of the observation, not their actual values. Okay? Now notice also that whether we started from an ordinal variable or whether we started from a numerical one, after we abandon the actual values and we go back to the ranks, what we've done is we're down to an ordinal variable, because if you notice now, the ranks don't really mean an objective measurable quantity. They just mean a quality: the lowest, the second lowest, the third lowest, and so on. So we're losing information. This is going to be very important to remember about these tests. Let's look at the key features of these non-parametric tests. Remember the 4 key features, the RRSP features that we need to look at. Well, what's the purpose of a non-parametric test? It depends. There are many such tests. As I said, this is a whole group, a whole class of tests, and each one of them has different purposes. Which statistics do they use? Well, as we said, they use ranks. They also use sample sizes occasionally, but pretty much just ranks. And they also produce various statistics, which, like the t statistic, the chi-square statistic, the f statistics, are totally useless, so you can ignore them. Okay, and then of course they produce the p-value. Without it, we would not be able to do anything, right? In terms of requirements, well, not much. Probability sampling is always independent data for most of them. Some of them actually do allow correlated data and take care of them, or dependent data and take care of them. And then for some of them also they use fixed sample size. But otherwise, not much else. No distributional assumption. Okay, robust? Well, you bet. Of course, they are built to be robust. Okay, so they are very much robust in this situation. In fact, there is very little that can go wrong with them. So, I mean, their robustness comes from the fact that there is not much that can go wrong. Now, here is one important point to consider. You may wonder, well, if in fact by abandoning these assumptions we're coming up with more robust tests, why not use these tests all the time? Well, it is true that fewer requirements mean these tests are going to be more robust, so we can be more relaxed about them and use them without too many worries. However, remember that we're losing information. We're dropping down from whatever level of measurement to just the ranks. And even if we start with an ordinal variable, we're still losing the information about those values, and we're going just down to the ranks. And that means less information, less power. And remember, one of the things that we want from a test is for it to have high power. So, non-parametric test should not be the first choice. If there is a parametric test, so ones which has those assumptions about bell shapes and all these kind of things that can be used, we should use it. Okay, but they provide a very good plan B in case we really don't feel that the original test, the best, the more powerful test, can be used. And this is the situation in which you're going to see these tests being used in all research articles.